looking at factoring and solving polynomials, mainly factoring. I'm actually going to skip all these notes at the top, even though I'm sure there's some excellent vocabulary. Let's just get right down to the math, okay? So sum and difference of cubes is something we've learned recently. Okay, remember you're looking for a perfect cube. That's x minus 3. And then you square it, multiply them together and change the sign, and then square it. Okay, that is now completely factored. Same thing on the next one. This is actually b and a 2a. Okay, if you take the cube root of both terms, again, square it, multiply them together, and change the sign. So that should have been a minus 2ab. And then you square the last one, plus 4a squared. Okay. Yeah, I like how I said change the sign and then I didn't. Okay, grouping, we've actually recently done that too. Okay, remember you group the first two terms. You say what is the greatest common factor there? That's just x squared. If I take the x squared out, I'm left with an x plus 2. Again, I can group the back two terms together also. I could take a negative 1 out of both of those. That leaves me also an x plus 2. Remember, we want those to match. So that's one of my factors. The other one comes from putting these two together. Great. However, we are completely factoring now, and this actually factors further. You know how to factor x squared minus 1. That's actually a difference of two squares. This factors to be x plus 1 times x minus 1. So my completely factored solution is this right here. Okay? A couple more questions. Here goes another one. Factoring by grouping. Okay? So again, I group these together. Greatest common factor there is a y squared. That leaves me a y plus 7. Group these together. Greatest common factor there is a negative 9. That also leaves me a y plus 7. So factoring that, putting this, that's y plus 7. This, y squared minus 9. Okay. This one also happens to go further. This is, again, a perfect square. Y minus plus 3 and y minus 3. Okay. Now, this isn't always going to work out like this. It actually very rarely is going to work out where you can completely factor that one after that. Well, I got a pretty good feeling this next one's going to work that way too. Again, first terms, greatest common factor, 9m squared. When I take that out, that leaves me an m plus 2. Looking at the back, greatest common factor is a negative 4. That leaves me also an m plus 2. Again, we want those to match. The other one goes together to become your other term, 9m squared minus 4. Looky there. Again, this one will factor further. That's 3m plus 2 and 3m minus 2. Again, that first factor, first term, stays out in front, and this has now been completely factored. Okay. This next one we have, so first is factoring. We're looking at factoring in quadratic form, okay? That means that you may not necessarily have a quadratic, but it could factor like a quadratic. So step one, still factor out the greatest common factor. In this case, that is a 3b squared. When I take out 3b squared, that leaves me a b to the 4th plus 2b squared plus 1, okay? Even though this is not a quadratic, okay, quadratic means x squared, I can actually factor this like a quadratic because this is technically b squared squared plus 2b squared plus 1, okay? If I replace those b squared things with x's, you could easily tell me how to factor that, right? That's just x plus 1 times x plus 1. It multiplies to be 1 and adds to be 2. Then you just replace these x's with actually a b squared. So these actually factor into b squared plus 1 and b squared plus 1. Okay, so you can do this is called substitution, when you say, oh look, I can call those x and just factor it that way and then plug what x equals back in. You can do that if you want to. I personally never actually do that. I just look at this and say, well, this term, the b part squared, is b to the 4th, so I can factor it quadratically. It's just going to lead off with a b squared. Okay. Let's look at another one to see if that helps. Okay. Again, greatest common factor comes out first. That's a 3 r squared. When I take that out, that's going to be an r to the 6th plus 3r to the 3rd plus 8. I feel like I just did that wrong. Now we're good to go. Not 3. That's what I did wrong. That's a 6. My bad. Okay. Sorry. Now I feel terrible. This can also factor quadratically, okay? Again, this is technically r cubed squared plus 6r cubed plus 8. So I could go ahead and draw my two sets of parentheses. They're both going to start with r cubes this time because of this one. That's what both of those are. And then plus plus is plus plus. What multiplies to be 8 and adds to be 6, 4, and 2. Greatest common factor of 3r squared hangs out in front, and this is now completely factored. But one thing to watch out with these quadratic forms are every once in a while you might have one where these can factor even further. Okay, this happens to not be a case like that, but something to look out for. Okay, this next one you may think greatest common factor, but there's actually not a greatest common factor of this, but these are both perfect squares. Okay, 256 is actually 16 squared. 81 is, of course, 9 squared. So this can factor into 9. Again, g to the 4th is actually g squared squared. So that's 9g squared plus 16 and 9g squared minus 16. Okay. Now here's one of these that what I'm talking about. This one cannot go any further because it has a plus sign and there is no rule for sum of squares, but there is a rule for difference of squares. These are still perfect squares. This one factors further into 3g plus 4 and 3g minus 4. Okay. This first term, the 9g squared plus 16, has to hang out in front. It can't go any further. Okay. This next one, I can start off by taking out the greatest common factor of 7t squared. I'm going to take out 7t squared. That leaves me with a t cubed minus 8. Okay. T cubed minus 8 actually will go further. Again, those are perfect cubes. That's a t minus 2. Square it, multiply them together, and change the sign. Square it. Greatest common factor stays in front, and this is now completely factored.